Bismillahirrahmanirrahim. Assalamu Alaikum. Dear student, welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus KPK Book Foundation Unit Physics SSC2 Unit number 14 in current electricity. Today we will discuss about SLO base according to FBISC requirement numerical problems question number 9 to 12 in part 3. Let's move the video. In this video, numerical problems question number 9. A small electric heater has a resistance of 15 ohm when the current in it is 2 ampere. What is the voltage is required to produce the current? First of all, according to statement, write the given data. In given data, resistance R is equal to 15 ohm and current I is equal to 2 ampere. We can find that voltage V that is equal to question mark. Using the formula V is equal to IR. According to Ohm's law, V is equal to IR. Solution in we know that V is equal to IR. This implies that V is equal to 2 multiplied by 15. 15 twos are 30, so required voltage V is equal to 30 watt. So the voltage V is equal to 30 watt. In numerical problem, question number 10. The question number 10 given statement if a potential difference of 10 volt is maintained across a 1 meter length of the Norcom wire having resistance is 3.1 ohm. What is the current in a wire? So first of all, write the given data. Potential difference V is equal to 10 volt and length of wire L is equal to 1 meter. Given resistance R is equal to 3.1 ohm. Now we can require that current in a wire I is equal to question mark. So using the formula according to Ohm's law V is equal to IR. Then in a solution we know that V is equal to IR. This implies that I is equal to V upon R. Putting the values, this implies that I is equal to 10 divided by 3.1. 10 divided by 3.1, this implies that I is equal to 3.22 ampere. Now the current is 3.22 ampere. Then we will move the next numerical. In next numerical, given statement, question number 11, what is the resistance would have 15 milliampere? Current is connected across the terminal of 9 volt battery. So, given data, current I is equal to 15 milliampere and voltage V is equal to 9 volt. So current in change into ampere, then I is equal to 15 multiplied by 10 raised to power minus 3 ampere and voltage V is equal to 9 volt. So required that the resistance R. Now using the Ohm's law formula V is equal to IR. In solution we know that V is equal to IR. This implies that I is equal to V upon I. So R is equal to V upon I, putting the values. This implies that R is equal to 9 divided by 15 multiplied by 10 raised to power minus 3. Calculate the value. This implies that resistance R is equal to 600 ohm. So the resistance of wire R is equal to 600 ohm. In next numerical problem, question number 12. Given statement. Consider a circuit with the three resistor R1 is equal to 250 ohm, R2 is 150 ohm and R3 is 350 ohm connecting in a parallel with the voltage of 24 volt battery. Find the current supplied by the battery. Now, given data, resistance R1 is equal to 250 ohm, resistance R2 is equal to 150 ohm, resistance R3 is equal to 350 ohm. Now the voltage of battery V is equal to 24 volt. Then required that current I. So we have in a solution for a parallel combination, the equivalent resistance of the wire in a circuit 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Putting the values 1 upon 250 plus 1 upon 150 plus 1 upon 350. Calculate the value and taking the reciprocal. So this implies that R equivalent is equal to 37 at 73.9, that is equal to 74 ohm. Now we can calculate the current in a circuit. So we can write that Ohm's law V is equal to I R equivalent. This implies that I is equal to V upon R equivalent, that is equal to 24 divided by 74. That is equal to current I is 0.3 ampere. Now for more videos subscribe our channel. Best of luck.